All right, friends, we are back. Algebra Chapter 1, Section 3. We're looking at multiplying and dividing real numbers today. We are first, before we get into numerical values on multiplying and dividing, we're going to talk about multiplying and dividing terms based on their sign, positives and negatives. If I start and I multiply values, two positives together, or if I divide numbers that are both positive, I'm going to end up with a positive result. It's when you have one of each that you get maybe a little confused. If I have a positive times a negative or a negative times a positive, that's when I'm going to get a negative result, whether it's multiplication or division. Positive divided by a negative is also negative. Negative and positive, one of each, negative. But then back when I get to two negatives, like negative 5 times negative 5, we know that's a positive 25. Or negative 50 divided by negative 2, positive 25. So don't forget about your signs here as we move into multiplying and dividing values right now. First example, again, if you can put on your Nikes, just do it. Mental math, that's great. Calculator's okay too. Again, we want to be efficient, quick, and accurate. So whatever you need to do to be both quick and accurate, you do it. We're going to improve this year and work together. Life will be great. So example 1, I have 35 divided by negative 5. So I have one positive, one negative. My final answer is going to be a negative number since I have one of each. 35 divided by negative 5 is negative 7. Heading down here to example 2, notice I have two negatives. Negative 11 times negative 4. That's going to end up at a positive 44. Example 3, I'm multiplying a negative 6 and a positive 7 together. So negative positive, I'm going to get a negative 42. Heading up to example 4, this is another way to write division, a fraction bar. 63 divided by 7, two positive numbers. I'm going to be at a positive 9. Fractions. How do I multiply fractions? Well, review here. If I have a over b times c over d, I'm going to multiply straight across, top times top, bottom times bottom. So that would end up being a times c over b times d. So let's rock and roll. So on example 5, 3 over 4 times 2 over 5, 3 times 2, I'm going to get 6. 4 times 5, I'm going to get 20. And of course I can reduce this dividing by 2. 6 divided by 2 is 3. 20 divided by 2 is 10. So 3 over 10. If you want, you can also reduce before you multiply this 2 over 4 as 1 half. 3 times 1 is 3. 2 times 5, 10. Kind of like eating a Reese's again, no wrong way. Multiply, reduce, or reduce, then multiply. That order won't screw you up. Example 6 here, I have a fraction negative 4/5. If you have a minus sign here out in front of a fraction, a floater, remember for a fraction to be negative, the minus sign can only go to the top or the bottom. If it goes to both, negative over negative, that would make the fraction positive. So I like to just take the minus sign and move it to the top term. That way I know I'm only going to multiply that minus sign once. So I've got negative 4 times 3 on the top, negative 12 over 5 times 8, 40. Negative 12 and 40 can both be reduced by 4. Negative 12 divided by 4 is negative 3. 40 divided by 4 is 10. So similar to my prior example answer, positive 3 over 10. Here I have negative 3 over 10. Big concept for today is dividing fractions, and we are never going to divide fractional values. Instead, we are going to multiply my first fraction by what we call by the reciprocal of the second fraction. So I'm going to keep my first fraction that I'm given, like in example 1, I have negative 4/5 divided by negative 8 over 15. So I'm going to keep that first fraction, negative 4/5, as is. What I'm going to do then is change my division to multiplying by the reciprocal of the second. Now the reciprocal of a fraction a over b, think of flip, that's just when I flip the numerator and denominator. So a fraction a over b has a reciprocal of b over a. I just switched the numerator and denominator. So I'm going to switch the negative 8 and the 15. So I'm going to go, 15 over negative 8. Now I'm ready to multiply top times top, bottom times bottom. Negative 4 times 15 is negative 60. 5 times negative 8, negative 40. These two negatives will make a positive. 60 over 40, I can divide both those by 20, and I'll have 3 over 2. Again, if you're not comfortable with those improper fractions, 1.5. You like decimals, 1.5. Those are all equivalent answers. Example 2, here is where we're going to see where a mixed number doesn't help us. I have negative 4 divided by 9 1/4. I'm going to keep negative 4, my first fraction. Well, is it a fraction? Yeah, it is. Negative 4, I can just write as negative 4 over 1. I'm going to change division to multiplication. But now I need to think of what's 9 1/4 as a mixed number. Well, I'm going to multiply the denominator 4 times my coefficient numerical value here, 9. 4 times 9, 36. Add the numerator, plus 1, 37 over 4. So 9 1/4 is 37 over 4 as a over b fraction. But now I need to multiply by 37 over 4's reciprocal. So that would be 4 over 37. I'm now going to multiply top times top, negative 4 times positive 4, negative 16, over 1 times 37, 37. Nothing to reduce here. Negative 16 and 37 are what we call relatively prime. Their greatest common factor is 1. Last example before we talk properties of 0. Again, I have a negative 3/4. I'm going to keep that first fraction. Change division to multiplication. And negative 9 as a fraction is negative 9 over 1. So I'm going to write negative 9 over 1's reciprocal. So that would be 1 over negative 9. Multiplying top to top, negative 3 times 1, negative 3. Denominator times denominator, 4 times negative 9, negative 36. And then reducing, negative divided by negative is positive. Both 3 and 36 are divisible by 3, so I'll have 1/12. And again, that's a positive 1/12 since I have negative divided by negative. Finally, properties of 0. Again, 0 is the center of our numerical universe, right in between the negatives and the positives. If you have multiplication of any value times 0, any number times 0, or 0 times any number, you are always going to get 0 as your final answer. Multiplication order doesn't matter. 3 times 5 equals 5 times 3. 3 times 0, 0 equals 0 times 3, 0. Division, however, order does matter. If I want to take 0 and divide it by any number, how many times does 0 go into 20? That answer will always be 0. Conversely, if I try to take some number and divide it into 0, that is going to be what we call undefined. The reason that is if you try to take something and divide it into nothing, unless you're a magician or maybe Chuck Norris, because I heard Chuck Norris can divide by 0, but you can't take something and divide it into nothing. That's impossible to do. So that is why that answer can't do it, can't compute it. Mathematically, we say it is undefined. 0 goes into something never, 0 times. But if you try to take something and divide it into nothing, no way, can't do it. That's the end of section 3 notes. Thanks again, and we will continue the journey.